I don't see why we need to save rainforests. They're just trees and plants.
Yeah, we have all kinds of trees and plants in our park. What makes rainforests so special? Rainforests have more kinds of trees and plants than any other place in the world.
How was the play?
It was good.
What were you in the play?
A giant anteater with a big giant nose.
A giant anteater? Where was your nose? I didn't see your nose.
No, I held it like this.
Oh.
It was just a little stick and then they made this paper.
Oh, well, we have to get you a bigger nose.
No,
Let me
but
see.
no.
Let me see if that looks like an anteater. Whoa, that's an anteater's nose if I ever saw one.
You say your point again to the camera?
You can write your government leaders and ask. That was
Say it again, say it again.
You can write your government leaders and ask them to set aside money that will help tropical nations protect their rainforests.
I have to go.
Oh, okay.
Take pictures of that. You got a cam?
Yeah.
Excellent. The batteries? We're going to talk about a little bit is metering equipment, digital multimeters.
It's a rotary load blower, and internally there's loads that kind of operate like this. They mesh together, and the benefits you have out of this is a full vacuum. This is pulling basically the same CFM of air out at full vacuum, where a regenerative blower, the higher your vacuum level gets, the lower you
Is a little taller.
I don't think so.
And they put the
We're still working on it.
muffler is a little bigger, comes out underneath, so it sits up on more of the skid mod unit, and it's got a guard.
Right, I've got new foam coming in.
But it's the
Our
same
platform here,
and
next size larger, pretty loud, about 90 decibels.
And a 10 horsepower motor, where this is seven and a half
right here,
horsepower.
where it was just a formed piece of channel and it was vibrating.
And then this has a filter.
So sturdied up standard platform, and then I've got new foam coming in, which is this is just a flat, cheap foam, and then I've got a higher.
It's called a cyclone filter, where the air enters there and it has to circulate around and go up over another lip before it can go in. So all the stuff is supposed to get trapped out the bottom of it.
Wait, Ken, I got it. Oh, you got it? Picture. How much are the replacement filters, and how often would you want to replace?
It's just going to depend on the waste that comes into them as to how often.
Okay.
I would imagine they can be cleaned out several times before you have to replace them. As far as cost goes, I can't remember offhand, but I can get that to Ken.
I think they're like $25 or something like that.
It's not a real expensive filter.
Okay. Is this a case unit to help muffle noise?
This is still in process. We're still working on it. We've got a better foam that I've ordered that's going to do a better job of cutting down the sound. But then we've got a fan that's going to mount here for keeping the enclosure
What did you call about that?
What's that?
What did you call about that?
About the foam? Well, I've got one that I didn't call one of those guys yet, but I've got some that's the what do you call it? The waves in it. Same 150 CFM that you were at 0. So it's a different technology, and it should be a big advantage. Also, this is 7.5 horsepower. You get the same thing you were getting out of, I think it was 11 horsepower with the others, so it's more efficient.
So your electrical bill is quite a bit less per month.
As far as this one, it's much more rugged than the regen blower. We repair a lot of regens, and a little contamination in there, and the bearing's going to go, sealed bearing, the bearing's going to go out in a couple of years, and this is much more rugged design. So should have a lot better lifetime.
You mentioned this. It looks very heavy to eliminate any vibration. What would be the weight of this unit?
We haven't even weighed it yet. It's definitely going to be something you need a forklift for. It's probably going to be too heavy for 2 guys to move around in. So it's 1/4-inch plate, so it's pretty heavy.
That is.
But the good thing they were pointing out is when this gets shipped, it's going to be easier to protect it from damage than just having a blower that you start having stuff knocked off. This thing is going to be the only thing that's going to have to be packed separately.
What's the CFM at 7.5?
This one's 150 CFM, but then we can make the blowers up to 250 horsepower, so up to 3,500 CFM at 15 inches vacuum to the maximum. So it's big range of sizes.
Sure. Let's do a close-up.
Okay.
Once the power comes into the main disconnect box, we take the single phase part of it and we bring it over here to this thing. It's an isolation transformer. It's a tappable transformer. And why that is important is because some places you have 208, like we have here. Some places you have 245, some places you have 220. The machine from there on wants to have 230 volts. So what we can do is, if you know what the incoming voltage is, you know you want 230, you can move the taps on this transformer to either raise the voltage or lower the voltage. How this works, we have 2 wires coming out, and those wires are 126 and 138. It's right here. 138 will always be connected to X1. It's also grounded, but it's connected to X1. Now 126 on this one is on X4. If I move it to the right, I'm increasing the number of coils in the transformer. I'm going to raise the voltage 10 volts from the incoming voltage. If I move it to the left, I'm going to lower it 10 volts.
So it increments in 10. It increments in 10, you're saying?
Yeah.
Okay.
So say you have 280 volts or 208 volts coming in. Okay. The X4.
And all those numbers are number coded.
There's a chart here, right?
Right.
They're also sticking this. They're taking a sticker, and they're sticking it on the same type of chart on the inside of the controller. So some on this one, but when they get shipped, this similar type chart gets on there. But this chart tells you what the primary voltage is, which is the incoming voltage. The secondary voltage, which is the voltage coming out of the transformer. So the primary voltage, say your primary voltage is say your primary voltage is 240, but you want 230. So H1 and H3 are jumpered, H2 and H4 are jumpered, which is all taken care of. We do that all here. The primary side is always set, you never have to mess with it. That's what we changed this transformer. It's always the same. So no matter what the incoming voltage is, you don't have to mess with the primary side, which is these wires over here.
The gray,
Black wires.
the black ones. On the gray side.
Yes. Now the transformer that we had,
What's the whole unit called?
isolation transformer. The ones you've seen previously, you had 4 wires in there and you had to move both sides to adjust it. That's one of the reasons we went to this transformer, is the only wire you have to move is this one. And if you
Wire
look at,
126.
yeah, 126. The secondary line. You see that the for 220, the primary lines are always on the same ones. Every one of those boxes are the same. For different voltages coming out, the secondary line is the one that changes. So say you have 240 volts coming in, and we want 230 volts coming out. So we say 240, we want 230, so we put the secondary lines on X1 and X3. Well, X1, you'll notice, is on all of them. Everyone has X1. That's this wire here, X1. You never have to move that one.
Can you see that? Yeah.
This one right here. The other one, if I'm going to go from 240 to 230, I take it and I put it on X3. So I would have this over here, which would take the incoming voltage and lower it 10. If I want to lower it 20, I put it right here on X4. If I want to lower it 30, I put it here on X5.
So the only wire in this whole component to move is just the 126.
That's right.
That's it.
Why would you want to lower this again?
Okay, say your power was too high or too low. It didn't measure 230 volts.
Right.
Okay? The machine, for everything to work past that, the machine has to be fed with 230 volts.
So if it's lower than
So if it's
230.
low, then you raise it. If it's high, then you lower it.
All right, because
And all these things work. It's a relative change. We don't have 208 on here. Let's say you measure 208 and you want to come up 20 volts. We can go to 220 on one side and 240 on the other side and see you need X1 and X6. So you know 220 to 240 is up 20 volts. So 210 to 230 is up 20 volts. You use the same setting. It's all relative.
if you don't do this, the machine will run, but it won't run as efficiently?
It won't run as efficiently, and you may have problems like stalling problems, because one thing this directly affects is the 65 volt power supply.
Stalling problems such as what?
Well, say
Machine just
if
shuts?
this is low, say your voltage coming out of there is 200, okay? That'll make your 65 volt power supply at 200, your 65 volt power supply will be around 54, 55, which is low. We want 65 to 68, right? Which means the motors won't have as much power as they normally would, which means if you try to slew or try to cut something big, you could stall. A real common problem causing stalls is the power supplies are too low.
I'm sorry, this is referring to the spindle?
No, this is the
The
stepper
motion
motors.
system.
Stepper motors.
So the whole machine could just freeze in the middle of...
No, it won't freeze. The motors won't have enough torque to move the gantry, so they'll slip.
They'll lose steps now.
That's right.
Okay.
It's really important that those wires 138 and 126 measure 230 volts, you know, within 10 volts for sure. 230 is perfect. The reason this is in here and we have these taps the way they are is because a lot of power is 208, and so we have to step it up. Which if you have 208, you just know. If I have 208 power, I just know I just take this 126 and I move it over to X6. Isolation transformers.
Mm-hmm.
The next thing, as far as AC circuitry goes, that's it. The inverter runs AC. We're gonna talk about that at the very end. But our main power, when we take out the single phase, the isolation transformer, from there we distribute it and convert it to DC power.
Mm-hmm.
Everything's DC power like your computers. It's all, even though you feed it with 110, it's got power supplies converted from DC. Okay. First one I want to talk about is this little beast right here. there's a toroidal transformer, a pair of capacitors back underneath back there somewhere. There's a right down here. There's a bridge rectifier. You can't see it. It's only about an inch square right underneath here.
Is it yellow?
No, it's black.
Okay.
Way underneath there.
What's the
So,
name? What's the name of this unit?
this is going to be the 65 volt power supply. I think we're running 68 volts right now. It's the stepper power supply. Hi, Jay.
Hey, Tay.
Can I interject with a silly question?
Okay, so this is our 68 or 65 volt power supply. That should be in there. Pick that out. The sole purpose of this is to provide power for the stepper drive. That's all it does.
What does it do?
Provides power for the stepper drives. Okay. What we do is to take the power off of the transformer, run it through a two-pole breaker. It's the only two-pole breaker in the whole system. From there, it runs into the transformer. The transformer, it runs into the rectifier. From the rectifier, it runs into the capacitors. And out from the capacitors, it runs to this wire into this little thing right here, which is this distribution. And from there, we wire it over to a terminal block, which is right here. 168, 178, I think.
That's the code, the number code?
Yeah. And from here, it comes out of here, falls over here, and goes directly into 168, 178, 168, 178, 168, 178. So they all come from the same spot. So one thing you want to always measure is your 68 volt power supply. Now you know ahead of time that if you've already tapped this to have 230 out, you know your 68 volt power supply is going to be 68. You measure right across the top of these capacitors. Take your probes on DC, 7 volts DC.
Okay, DC now instead of
Yep.
AC.
Everything from now on will be DC. Measure right across the top here like this. Now, there's no power here, so we're not going to get anything.
What if you had that on AC? You just wouldn't register, right?
Yeah, we measure.
And same thing on the 220 at the wall AC?
Yeah, usually if you measure your 220 circuit on DC, there always seems to be a little bit of voltage there, 1 or 2 volts.
Right, okay.
But it's nothing significant.
Right.
Okay. I want to talk a little bit about this resistor that's right here. This resistor in there it's a safety device. Capacitors, it's a very high. This is like 10 watt, 1 kilojoule. It's like 10 mega ohms or 100 mega ohms. It's a very high resistance resistor. Capacitors, if you understand anything about how they work, capacitor is kind of like a battery. You charge it up, and if you just disconnect it, it'll keep that power. And the battery flash is just a capacitor discharge. So the power will stay there. So say you turn the power off and you were working on something, and we didn't have that in there, those things would still be energized, and you could get shocked. What this does is it allows the power from those capacitors to bleed out over a short amount of time. If you were to put your meter on there and measure 68 volts, turn the power off, you'll notice when you turn the power off, it takes about 3 seconds. It'll go down to 40, then to 20, then finally to 0.
About 30 seconds.
3 seconds. 3 seconds. Yeah. It takes 2 to 3 seconds for that to go. Yeah, it takes 2 to 3 seconds. Not near as long as it does for this to discharge. Everybody always asks me about what that thing is there for, and it's a safety device.
Mm-hmm.
You always want to make sure it's there. One thing you can tell, you were talking about high voltage. What do you do if they hook up high voltage?
Mm-hmm.
What happens? This will explode if they hook it up to high voltage. This thing, it'll just come apart.
The resistor?
The resistor or the
Yeah, the
actual?
resistor will. It'll break in two, or it'll turn on black.
So it protects everything else, and so you only have
Well,
to...
no, it doesn't. It doesn't really protect anything. But what it does is it tells you if they've hooked it up to wrong power. That's one of the signs you can look at. If there's a lightning strike outside and you get a voltage spike comes through, that'll blow up sometimes. But he didn't want to measure any voltages. Finally, I talked to the customer and opening up the box, and this breaker was tripped. Well, we always strip this breaker when we ship it out. We turn these off.
Right, you have to put the breaker on.
Yeah. Well, so you have to turn it on. So you can measure that. If you measure that and you got nothing, well, you know, oh, I got to flip the breaker back on. Then you can flip the breaker back on.
So you measure at the top blue capacitor.
Doesn't matter. Doesn't matter. You can measure right here like this. You can measure right here like this. They're the same. If you want to be brave and stick these things in here like this, you can do that.
What reading do you want again?
In the mid 60s, 68, 65 to 68.
Yeah, okay. If it's off by a couple, it doesn't matter.
You totally recommend when on an install, when the machine's first there, it's got power, just to open this up and make all your measurements,
You got
make
to.
sure that they're correct before you start to run a job.
You
or
got
something,
to.
do all that stuff.
Yep, you got to. Next one we're going to talk about is 24 volt power supply. We're going to start from the top and work down, which is this little piece right here. Now the wires coming out of it is 348 and 358. 24 volts gets distributed all over the machine.
Where are those wires?
They're coming out right here. It's these two coming out right here.
Okay.
It's 348 and 358. But they go to a terminal block right here. And this terminal block, it's a distribution point because 24 volts gets used on all the limit switches, the pause circuit, the e-stop circuit, any limits for drills and all that, those kind of extra stuff, all comes from the 24 volt power supply. Power supply we're using currently is a regulated power supply, so you should just measure it. If it measures something that is say 12 volts, then the whole supply will need to be changed. It's not there's no adjustment on it. It's a regulated supply, so this, unlike the 65 is not regulated, this is regulated, which means if you feed it 210 or 220 or 230 or 240 or 110 for that matter, this will still give you 24 volts. It's got some internal circuitry to sense the incoming voltage and adjust it so that the outgoing voltage is 24. It's what they call a regulated power supply because it regulates itself. All these devices in here are pretty much plug and play. The 24 volts, since there's some solder connections here, there's two short wires coming over here. So say you were going to replace a 24 volt power supply, what we send out is the whole thing with these two wires already connected and these two wires already connected, and you just go back and you connect these two back into here. I think it's 138 to something, 240, 340. They get connected back over in here, 138 and 340 or something. It's down in there somewhere.
What's the frequency you'd have to actually replace that?
We've sent out about, like this, probably 400, and I've replaced one.
Yeah. I don't think it's a problem.
I know
It's a regulated power supply, which means, number one, we're paying more for it.
Right.
Number two, it's much more reliable. What were you saying, Jay?
Yeah, I know that 5 volt power supply is responsible for supplying power to the pendant. So if something didn't work on the pendant, then a red flag would say check the 5 volt power supply. Is that correct?
Possibly. It depends.
What would the 24? What is the 24 volt power
24
supply
volt
responsible for?
it powers all of the limit switches, emergency stop, and the pause. Those are the main things it does. So if you turn it on, one of the things, the telltale thing, because it's also fused right here. 24 volt power supply is it's fused. You turn your power on, it comes up and says external halt activated, emergency stop or something like that. Even if your button's pulled out, if you don't have 24 volts, it will say it's emergency stopped. You have to have 24 volts to turn that on. So that's one way you can tell. And it's easy to measure. Measure right at the terminal strip. Usually if your 24 volts is not working, that's what you'll see, because on the hierarchy of things, the emergency stop light takes control over everything. You wouldn't notice a limit switch not working because your 24 volts is bad. And here's the 5 volt power supply. And this one, if you've looked at anyone's before, it's this thing up here with this cage around it. You'll notice that it's much different than all the ones you've seen before. We've changed. This is a change Dwayne made. That's actually been a very good change. We wanted a little bit more reliability than 5 volt power supplies. The condors are real good, but over time they would degrade and you have to turn them off with the little pot. I know you've done that with yours, even if you don't remember. I know you have. This is a medical power supply. They use this in things like to supply the things for like the heart charger, the electronics for that. That's all got PC boards in it. The EKG, it's got one of these in it. The EKG machine. Yeah, it's a medical. It's a 40-watt medical supply. And we're paying a little more for it, but since it is a medical supply, it's supposedly very, very reliable. I haven't had any problems with any of those at all. Degrading or just not working. So that will be there's no more adjustment as far as 5 volts. It's adjusted before it gets to us. I've been measuring them. They've been measuring 498 to 502, 503, which is right where it needs to be. So it's not. It won't be a change part probably. If it does go out, there's a terminal strip down here on the bottom of it. We just send you the whole thing, cage it on, you plug a new one in, stick it on, and go. The only thing it supplies power to is a PC board. Now Jay was saying that it goes to the pennant. It goes to the pennant through the PC board.
So essentially all these electronics in here are just plug and play.
Everything in our controller is pretty much plug and play.
I mean, you could switch these out, piece of cake.
Yeah, that's the whole idea behind it.
How does this compare like competitively?
Nobody else is like this.
Nobody?
Have you looked at like a Gerber controller? One thing that we can sell against pretty much everybody else is the numbering system we use. We've got every number wired, every terminal block wired, and there's a schematic that goes along. You can easily find what that wire does, where it's supposed to go. Nobody else has that.
Mm-hmm.
It's a really good thing. Next thing I want to take a look at real quick is the new M24 interface board. Mostly just because I've never seen it before. That's the one over here. If you notice the current boards you guys have seen, there's a lot more stuff on it. Well, yeah, I just got these plugged in because I'm testing.
Oh, okay. That's what I was freaking out about when I saw it.
This machine must be a multiple-headed.
It's got like 15 heads and 4 automatic masters.
That's exactly why they're there, because I'm testing multi-head, because tool change, I'm testing all that stuff to make sure they come on.
I see what it's up to.
I very guy.
Oh, okay, I was gonna pocket that since they wouldn't send us one.
What are those, Tommy?
These?
Yeah.
This is an opto. This is actually, we're not using this kind of opto anymore. It's like, oh my god, we're using, we went back to opto 20.
In that case, I'll definitely pocket.
This is it's basically a switching device.
Mm-hmm.
There's 2 contacts in here that the controller turns on. Turns it on in here, which turns on this light, which makes these 2 contacts turn on, which are wired to, and this one will be wired to this plug down here, a couple of these wired. They're turning on and off different devices. Turn off the drill, turn on the drill, turn on the spindle. This is the spindle one right here. What that does is the controller closes a circuit in here, which closes the other circuit in here. That closes these 2 wires. We go over to the inverter that says turn me on. Just a switch. These are switches that we can use in the controller.
Okay.
One good thing about the M24 is we added a whole bunch of these. We did add quite a few. We took out the 4th head. We got 3 heads, 3 misters, 2 drills. We have a caution light we added, tool change tap, tool change glass, dust. We've got a dust collector output. We've got 3 miscellaneous outputs, and we have a couple for the servo. And it's all labeled on the board too.
Dust collector
That's
output.
what I was just about to ask. In fact, I had somebody install a week or two ago, whatever the last install I did was. Oh, it was hair. And they asked if there was hair.
On the new board, there is an output for that.
Where would you wire it up? Where would you
Oh, you'd wire out that. You'd wire off of here. You put in a new relay. You wire off the opto into a relay and use that relay to close.
That makes
some
a lot of sense
contacts
just
or
to have
something.
the dust collector going.
Yeah, it'd be great. What's your pause light? I mean, your caution light.
Oh, we have a caution. We put a caution on too. That'll turn on anytime the spindle's going also, or anytime there's movement. Turns on. It's for like if you wanted to put it. It's on there for like CE spec. If you want to put like a flashing yellow light or a horn sound or something like that when it's going to move, you can do that kind of stuff.
Dig that. That's cool. You have a wireless for sound.
On the air.
No. What?
A little on the air.
It's just a warning light. But the key thing about this controller, if you look at all the other controllers or a previous controller, is all this has been moved. All the circuitry has been moved into 2 field programmable PLDs. We're programming them here. You won't ever have to, but it's kind of nice to know that if something happens, it is field programmable. What those PLDs are essentially a series of just gates. We have been able to put things inside those PLDs that say if the air pressure switch isn't turned on, you can't run the machine. We're like a tool changer. We have an input for an air pressure switch. You wire up the air pressure switch. If there's no air pressure, it won't turn on. The PLD on this board won't let anything happen. There's a bunch of safety items in there.
While we're sort of on the subject, you say that we're not using those anymore. Is it a different kind of opto, but the same?
Oh, it's just a brand.
Oh, just a brand.
This is a brand name, and the reason we changed from this brand name is I couldn't get the hole with this bolt through. Behind the M24 right now, it's all M23. All the new stuff here will be this M24. On the back side of that is an H971 board instead of the G971 board like you're getting now.
3 boards or 2?
2. One of the important changes, and one of the changes that to be aware of, on the H board, all the pendants are serial pendants now. There is no more parallel pendant. So there won't be any like setup and that kind of stuff as far as the parallel pendant go. Isn't anymore.
So going into DNC, you don't have to pick serial or
The
parallel
DNC
anymore.
is completely different. We're going to go over some of that stuff tomorrow. Yeah, there will be there's no pendant selection. You missed all the section I was talking about the new stuff, but some of the stuff was pretty cool.
So there's no more.
Besides that, we have stepper driver boards. Hopefully everybody's already a little bit familiar with those. If you change these, again, you just have to take out the 2 bolts holding it on there. It's all pluggable. All the plugs are labeled. All the drives are labeled now too. And come to think of this, actually, everything is labeled in here. We started putting on these little stickers. You can't really see them unless you get down and look at it, but there says PS1, 5 volts DC, tells you what it is. Right here it says switch SW1 on off. Inside the schematics, which I have set right here, that we're going to look at in a second, there's things on here that say, let's come back here and see. Let me find it. PS1. You don't know what PS1 is? There's a big label right there that says PS1, 5 volt power supply. This is what it is right there. PS2, that's PS2. Well, down here it says 348, 358, 24 volts DC. So we look at here, and there's a label probably right up in there. It says PS2, 24 volt power supply. So the labeling in the controller has increased a lot. There shouldn't be any more question about like where to find the 24 power supply. If you look, you'll be able to see it because it's all labeled, which is a really good thing. Let me see, what have we not covered yet? 3-pole breaker down here. This 3-pole breaker goes for the only thing that uses 3-phase in the system, and that's the inverter. 3 wires coming through here. This is the on-off enable circuitry for the inverter. This one's e-stop. You don't really need to worry about too much about what those are, just that there's 2 contactors in there.
Which switch is always tripped before when you ship it? You flip the switch.
Usually they trip these both the breakers.
Okay.
They usually just reach in and flip both the breakers before. That kind of protects us a little bit if they do hook up the wrong power. Maybe this power supply won't be destroyed.
Right.
The breakers.
The electricians that have been putting power out there must be putting those on then, because I've never had a problem with those where
Could be.
shut off.
They almost always shut them off.
Right, shut off and on.
The 3 cubes right here, these are just regular relays, 24-volt DC relays. There's this little, they put a tie wrap around them to hold it on to keep it from being vibrated out during shipping. Let's say a relay goes bad for some reason, you can cut that, pull the cube off, and replace the cube.
What is this?
This relay part right here. This gold is 2 separate pieces. There's this gold cube on top, and there's a gray base. We hold them together with this tie wrap just to keep it from falling out when it gets shipped. But if this relay goes bad for some reason, you can cut this tie wrap and the relay pulls right out. Let's just snap a new one in. You can send you a new one, you can put a new one right in there.
It doesn't rely on the strap to be hooked in, right?
No.
Okay.
That's
Okay.
the tie wrap is there to keep it from falling out when it gets shipped. All this down here is power distribution. This is 178, 168, which is power coming off of, probably coming into the transformer. One breaker here, 346, 348. There's a fuse. These new fuse boxes we're using, you pop them open like this. The door pops open like that, and the fuse is in there. You can't hardly see it. Just get up close, but there's a fuse in there. They all work the same. That one's for the 24-volt power supply. But there's also 4 more fuses up here. They all work the same. They pop open, the door flips up, and the fuse is held inside there. So the fuse has changed a little bit. One change we've made probably about 3 or 4 months ago are the style of terminal blocks that we're using. Previous machines all had screw-type terminals. That's how yours has. None of these in here are screw-type terminals. All the distribution, you take the little screwdriver and you push it in and it forces the thing open. The good thing about that is as it gets shipped across the country, the thing vibrates and it actually has better receiving.
Those screws suck.
Yeah, we don't use this anymore. It took us a long time to go to this because they're quite a bit more expensive than the screw terminals, and we use a lot of them. There was a cost issue along there because we just decided not to go currently do it. You also notice on the back side where the main incoming power is, there'll be a block like that, a box like this. It's got those same type of terminals. Just a larger size. That's where it gets wired up. Yep. Your electrician would bring his conduit to right here, put his wire through here, on there. Now this one has a straight on the flat. Most of these, this is probably one of the last ones. This side is at an angle, so there's more room for the wire in there. And this is my testing controller. Actually, this is the same controller that was at the ISA show.
This exact.
What?
It's the only thing we haven't talked about.
Let's say it looks different. It's smaller.
That's the same 2 horsepower inverter we've used for the last 2 years. Probably because you don't get too many 2 horsepower.
That's probably that. I'm sure that's it.
Yeah.
This is a 2 horsepower.
Just checking to see if when you get them on.
No, it's a 2 horsepower VS Mini. You can tell, a lot of times you can tell what horsepower it is by looking at the inverter. A VS Mini is always for a 2, a 606 GPD, can be for a 4, 7, or a 10, depending if it's a 23P4 or 22P5 or whatever the numbers are. But it's good enough to know that a particular inverter that's ordered for a machine that has a particular spindle on it, say you order a 2, and the customer later decides I need a 4, you can't just put a 4 horsepower spindle on there. You gotta put a new inverter in there. So it's completely different.
Will the inverter for the inverter for a 4 won't work with a 2?
The inverter for a 4, you can go down.
You can go down, you can't go up.
You can go down if you program it, but you can't go up. Hopefully lunch is about here now, because we're in a breaking point. Here is make our controller, at least the electronic part of it, as simple as it possibly could. All the parts are plug and play, except the inverter's program and play. We've gone to some regulated power supplies, 24 and the 5 that have increased the reliability. We put more money into buying better components in here. I think we're going to be with this controller for quite a while.
I have another question. This might be a question sort of as a user, but also both ways. The box attached to that beam, okay? Assuming that this whole panel is on one side of the table and you're doing engraving on the other side of the table. Assuming you're all the way to the other side, how far does it go?
It goes about that far. Remember, this is a 22. This controller is 22.
You're talking about a 4x8?
44 gets a little longer cable.
I thought there was a certain length before you start distorting information or what.
That's actually a good point. On a parallel cable, that's true. That's if I'm on the H board,
right.
There is no parallel pendant. It's all serial pendant. Remember we talked about that a while ago?
Yeah.
It's all serial? Okay. That's one of the reasons we did that. Because like a serial communication now is the same type of communication you use, say, from your computer to the controller. We can go 2, 3, 4, 500 feet with an amplifier. We could do the same thing with the pendant now if we wanted to.
So I could stretch a pendant out wherever I want.
You could.
With serial communication, then there's no more.
Yeah,
no more
you can
parallel.
Yeah, there's no more parallel. I don't know exactly how long we're going to be making those to pull off of there. I don't know if we can be able to reach it all the way to the back. I don't know that anybody's really discussed that yet. I know that this whole ARM system right here is still kind of a development project. I don't know that we've gotten our final. I'm sure we haven't got our final design. I don't know what the final design is going to exactly look like. I actually had an idea where we have some kind of coil system that retracts back in there instead of like this because
I was thinking right along with that term. It's a very good idea.
It's a good idea, but it's just really
hard.
expensive.
Yeah,
it's not that hard, it's just really expensive. That's not something we could do without increasing the cost of the machine. And we all know that the market right now is pretty sensitive to cost increase.
Obviously, trying to figure out what the hell the problem is when the problem occurs.
The only disadvantage, I would say, going from stepper to servo is cost. Servos are more expensive. You can generate much more power with them. That's what comes around with pros. You can generate a lot of power. You can generate a lot of speed. Reaching 6,000 RPM motors.
Do they have a What's the disadvantage of the servo?
The disadvantage is they're more complicated. Running to a stepper motor, you have 4 wires going up there. Each motor has 2 coils. Each coil has 2 wires. There's 4 wires. Now going up to a servo motor, you have 4 power wires to power the motor. Then coming back, you've got 12 or 14 encoder wires that measure different things as far as position feedback goes. And it's easier if one of those wires gets broken, it doesn't work. So it's a more complicated system as far as that goes.
When would you know to say, okay, you need servos instead of stepper motors?
It's pro versus.
I don't like from the application perspective though. Customer says, well, do I need servos or steppers? What would your opinion be?
Well, you look at if you're going to put them into a pro or an SF. All pros are servos, all FS are steppers. All.
They don't have the option?
No more option.
So about to say, because it's 6610 in Indiana, had servos in it, it really has.
No more option.
No more option.
Yeah, because if you're gonna go for the pro, you know.
Tommy needs to talk to you about that.
I'm sure he does.
Application is large, you know, heavy wood or something, then you move them in pro. If they're a typical sign shop or like this engraving you're selling to, then an SF or an MT is fine.
The wood would need the servos because they need more power and accuracy.
Yeah. What the wood industry has is different from the sign shop industry. The biggest difference is the size of the cutter. That's why you use 10s instead of 2s, because they have cutters that are this big around, not little tiny cutters like your finger. And it takes more horsepower to turn those big cutters. That's the same reason why you need a bigger machine.
With respect to our servo motors, you know, you hear about servo motors out there being a little unreliable sometimes. Our servo motors are really top notch.
This system we've had is very reliable. I think we've had the few problems we've had with it have been like the wire's been cut on install or something like that, where it's an obvious thing.
That's not true like of other systems. That's not what I've heard. You know.
I don't really know too much about it. I know one advantage of our system is we are feeding the stepper drives with essentially a step and direction signal. All the loop back information is controlled internally to the drive, which means that the manufacturer of the drive and the motor, is a lot more reliable than say the first systems, where we control the servo amp with our controller. It just introduces one more variable. It's a good system. It's almost, if something goes bad on it, it's almost plug and play. There is some servo amp programming, but one of the things, this is something that's coming down for the future. We had a meeting not too long ago with the inverter people and the servo people, and this is like probably a year away, but this is something that's definitely coming down the line, where you're going to be able to turn on the machine. It's going to know from a flash location what horsepower spindle is, and if your inverter's not programmed, it's going to program your inverter. And if your servo amps aren't programmed, it's going to program your servo amps. So say an amp goes bad, you just plug in the new one, and the next tower up, it automatically gets programmed. Same thing for the inverter, you don't have to worry about programming it if you have to change it, it'll automatically do it. Or say you were talking about going from a 4 to a 2 on an inverter, you change your flash location to a 2, it loads a different set of parameters into the system.
Flash upgradable.
Well, all these, they all have serial communications on them.
7 to 2, you can do that as well.
Yeah.
So anything down.
Yeah. You can program, you can always program down.
The only difference.
The inverter's bigger. The line reactor on there. There's an extra stepper drive.
And this is a 4x4 and 4x8.
SF is going to have a linear fuel change on it. The biggest obvious change is how the Z is put together. comes through the top plate that's on the Z to a pulley. Goes back to another pulley with this belt, connects to the Z motor, which is now inverted underneath.
They know that we got to work with it.
Tensioning block right here with the bolt on it. The whole thing can be, the belt can be tensioned in there. There is
Cover that goes over there?
yes. There's a cover that goes, a plastic cover that goes over this. It's like that.
Okay.
You can't see this. That's right. It looks like that. Okay. The motor for the Y is the same as on the current bus. That hasn't changed. Part goes in there, you pull it forward. What has changed is you really have to get the Y in there tight if you were, say, building one of these from scratch before you put the Z on. It's real hard to get to that back wall.
So this is the Y right here.
Yes.
Well, we wouldn't be taking that on and off.
Not unless there was a problem.
Okay.
On a regular install, you would never open this.
Right.
It's just there. Okay, this is how it goes together. All these motors are plugs now, like that, so you don't have to do any wiring on the X. You just plug them in. This particular one, because it has a tool changer, has a couple of solenoids mounted in the back. Open and close the check. That wouldn't be on a standard system. It's on a tool changer system. This part right here.
From the what?
From the going from the Plus to the SF. The big difference is these tubes right here. The cable is now welded and milled instead of bolted together aluminum. That's all steel.
This is a Pro right here, right? I mean, Plus right here.
So actually, this table, and I think I saw it yesterday, you take this whole table and you set it and you just mill it like you do the tabletop, so it's totally accurate.
Now we mill these datums on the side here.
Right.
We're not milling the tabletop yet, but that's something that we probably will be doing. The other change from the Plus to this one is in the side plate. This plate has changed right here. Okay. We changed it for two reasons. One, we like the look of the shape a little better. Go figure. The other thing is what we did is the bearings that are on here, we've increased the bearing stance by an inch. Okay, that gives us more rigidity and more resistance to torque on the gantry this way because we've increased the bearing stance.
Okay. So you pull them out further, right?
Yeah, the bearings are
Right.
spaced apart an inch farther than they were on the Plus.
What does that do again? No, I'm serious. Why did it do
It gives us more resistance to torque on the.
Oh, okay.
More resistance.
Right, it can't sway.
That's right. It makes the whole thing probably
Stable.
15% more rigid, 20% more rigid.
That makes sense.
Just because of that. The transmission assembly is exactly the same. That hasn't changed in quite a while and probably won't change. We are putting plugs in all of them. So when you get these, it's all plugged. It doesn't matter what side that goes on. Used to before you had to watch what
This is foam here.
yeah.
That's what makes this gantry light. Is that correct?
That's what makes it light. It's what makes it a lot stiffer.
A lot stiffer, but without the heaviness. Isn't that a competitive advantage?
It is. It stiffens the gantry up without adding a whole bunch of weight.
Right, so it can still go fast when you need to go fast and powerful when you need to be powerful.
We measured these one time. We had a guy, 250-pound guy, stand on the gantry. We'll measure the bottom. The one that was filled, what was full. We put a pressure switch on it so it won't run unless you have air pressure.
So that's for the tool changer that he's regulating.
That's good. That's very good.
Regular. You know, I had to really like to step back. There's a mechanical fan in here that is on the end of the top end of the motor shaft. Okay, that's gone. There's this little muffin fan here on top, enable the spindle, the muffin fan turns on, it just stays on all the time, whether you run the spindle's actually spinning or not. So you get, one thing, you get consistent cooling, slower RPM, you run slower. Before you didn't go up there, so your fan wasn't spinning fast. This you get consistent cooling all the way through. Plus all the spindle noise comes from that fan. That's where it all comes from. This thing just runs dead quiet. And they haven't hooked up the box, but this is all it is up tomorrow. We'll probably get it done in the morning. It's just dead quiet. The difference, then up here we got.
So these tubes are welded.
Yeah, it's all welded in.
This is the SF machine?
Remember all that?
No.
Just the frame. Getting ready to put the bearing rails on. The thing to notice about this that the rack and the bearing rail is one piece. This is a very important thing. Keeps the consistency between the rack and the bearing rail. The other thing that's important about this, these bearings are roller bearings instead of ball bearings. Now, the ball bearings we use on the SF, there's on each bearing there's 4 rolls of ball, so you have 4 contact points. And it's a point load. On the roller bearings, there's 2 rows of rollers on there. So instead of having a point contact, you have a line contact. And what that does is it distributes the load over a line instead of just a point. So you have much better load distribution. What that allows you to do is carry heavier loads.
What's on the Pro series?
Yeah, all the Pros is standard on all the Pros. This is a generic or a basic Pro controller.
Pro controller?
Yeah. The things are the same transformer, same 24-volt power supply. This one doesn't have the new 5-volt power supply, but they will. It'll be located in the same spot. The controller board will be right here. Instead of stepper drives, 1, 2, 3, 4 servo drive. 1, 2, 3, 4 breakers for 1, 2, 3, 4 drives. I don't know what they're doing here, some kind of test to see what's going to be better. I'm going to go to a shorter step here with the motor. Is this an old one that's being updated or upgraded? Or no? Okay, I am right this time, but the inverter's different. In this case, the inverter is different. This is a one-of-a-kind test inverter. Oh. But the inverter will always be at the bottom, down there. This right here looks kind of like the 65-volt power supply on the other one, but it's smaller. And that's because it's exactly what it is. It's a 65-volt power supply, but instead of having 40 amp capacity for the drive, this has about 10 amp capacity because it only drives one drive. One stepper drive. This one happens to be a tool changer.
As opposed to the stepper motors.
Yeah. The servo motors for this, the rotator motor for the tool changer is always a stepper. And that's what this is. The motor to rotate the tool holder. So you can tell, I can look at this and it's not attached to a table. You can tell immediately what it is. You know it's a Pro because it's turbo drives. You know it's a tool changer because it's got one stepper drive. It's full 32-bit Windows compliant. We'll run on NT, run on Windows 98 and 95. It's got an installation program that sets it up for you. There's no more making your own directories and copying it over. When I'm through with the installer program, it'll do everything except change your clone, change your cat box or whatever. It'll do it all. We bought an install shield program to do that. Makes directories, copies all the DLLs over. MX32, because it is a full Windows 32-bit compliant program, is not like MX the past where it was one program. There's 5 shared DLLs and 2 DLLs of just for it, so there's a lot of files coming out just in one. There's no longer a config mover file either. What we have instead is It's a control panel output. Everybody knows what the control panel is, right? We got this one here that says motion controller. The motion controller output looks like this. In general, it's going to come up and say new motion controller. It'll always say that at the beginning until you add or change one. I just left the name of it there. There's a tab for DNC settings where you can set your DNC path. This is just like the DNC path for the current version of DNC. Your job history files like the DNC log. It keeps it in a Microsoft database now. File extensions are similar to what it was before. It's the same type of terminal settings. We can take all the comments out when they're downloading, so you can have comments in there. Predict extensions using Smart Download. That just tells you that if you try to use it, load a .NIT file, it's automatically going to come up with EC files. Refresh and revamp whenever you enter the machine parameters. When you get here, and I'll show you what the machine parameters is. It will automatically download them from the machine. The way it's set up now, the current version of MC Setup, it automatically does this. But we wanted to be able to change flash files without being connected to a controller. So you can run MC Setup and work with a flash file. So say a customer's having a problem and he doesn't understand how to run it or whatever. You can take a flash file, modify it, and save it. Send him the flash file and he can just download it directly to the machine and it'll make all the changes. Because they've lost some bit of information that the computer sent into the router. It gets lost.
Why would that happen?
You're running near a fluorescent light is a common thing, and you get some interference, or the cable's not plugged in there quite all the right way, and you just lose a bit of information. You don't have to lose a lot, just a little, and it'll do weird things. What this packet-based communication system does is the controller sends some information to the router. The router sends it back either saying yes or no, it was good or bad. If it gets one that says bad, then the computer resends it. And it keeps resending it until it gets back at good.
Well, this is all something the customer can run?
Oh yeah.
So if a customer's experiencing problems with the machine going haywire or something like that,
turn on secure communication.
Just turn this on. It will tell him if it's a communicative problem.
If it goes away, that'll pretty much narrow it down. This is going to be for 100% reliable, perfect communication. There won't be any, because it'll keep sending until it sends a good one.
Oh, so this will actually check it and then resend it.
Yeah.
So the controller won't even accept the file.
That's right. It keeps sending it until the controller sends back to the computer, yes, I've received good information. Send me the next piece.
That's very good.
We talked a little bit about job queue earlier. This is where you tell it where the job queue file is located. That's pretty much it for the applet. The program itself. Actually, that was kind of an interesting thing to see. Started it up. So I'm going to go to terminal. It says feature unavailable. The way we've got this program set up is in the shortcut, you have to have switches turned on to turn on certain functions of the machine, of the software program. There's a whole list of switches, about 8 or 10, and they're in that book. There's a printout of them in that book you guys have. Terminal, DNC, super, params, a number of different ones. If the customer tries to access a function that they don't have a switch turned on for, they get this error. So that shortcut doesn't turn on, but this one is. First thing we'll look at is terminal. Okay. Yeah, we're working. Terminal mode is just exactly like the MX that you've all seen before. It's the same thing. If I want to reboot this controller, I press the F4 key and I put in 144. Kind of reboots the controller. I get back the same kind of information. I can tell he has KDM version 4.01 in here. We're actually going through this cable connected up to that controller out there. So everything's okay. Now the way the file system works with this new stuff is quite a bit different than the file system we have now. We have basically 3 files in the current system: a firmware, a NIT file, and a flash ROM file. The new system has an additional one. It's got firmware, which is same as it was before. Then it's got a loader file, which every machine will have the same loader file. Doesn't matter if it's a 44 tool changer or a 48 SF or a Pro or 22. The loader file is the same. The next one is there's 4 files that can go in the next location. A standard file for a standard machine, no miscellaneous options. An ATC file for ATC machines. A knife file for knife machines. I think there's one more. I don't remember what the last one is. Nothing. We haven't developed it yet. Anyway, so you can get an ATC machine, load the standard in one location, the ATC in the other one, and then when you boot up, it'll come up and ask you, do you want to boot up in ATC or standard mode? So you can run an ATC just like a standard machine. Say the tool changer breaks for some reason or something happens like that, you still want the customer to be able to cut. You can have him just select standard mode and he goes about his business.
And that's where? Inside the software?
Yeah, I'm going to show you how to do that right now, because we need to get this machine loaded, basically. Under the file menu, there's a bunch of items. One thing I talked about earlier was a project. I'm going to open a project, and right now I'm on the 22 MTH project because I've been working on this one. So I don't want to use that project. I think I want to go to the 44 project. So now I've opened up the 44 project. What that did for me, is it changed all these settings in here to read for the 44. And I'm actually going to change, I guess, a couple of these since we've changed. Oops. The init file is the loader file. It's HLDR is the name of it. I'm going to put this one in here. I'm going to change some of the stuff to the network since I got a new version yesterday. So that's this one right here. The setup file is also there. You'll see what all these do in a minute. This one will go to 44. Firmware 343C is the right one. Off the network. So I was saying your project settings for your different customers. If you have a directory in there with your customer name and you keep their files in there, you can have the project point to those files. So if you change projects, you can change the files so you have the whole list of them at the same time instead of one at a time.
Each customer will have their own project
That's
file.
right. See, right now I'm set up for like the 44 SF. Okay, I can go back to. Oops. I can go back to the 22 project, and if I look at project settings there, I'm on 22 stuff.
Yeah, but you're opening those files by machine, not by customer.
You could rename them to any customer.
I name my machine because I'm working on
Right,
development
but
stuff, but you could name them by your customer. Yes, that's the idea behind it. Again, we want to stay with the 44 because that's what we're looking at here.
Well, what would you want to know about that?
What?
And so that you could have them go into their project file, and then you could see if they change anything, so that could be the problem?
I'm going to want to keep backups to customers I go to because then I know what I left there. I don't have to rely on just remembering or their backup copy of their install disk. Which brings me to another point. MX, or the motion control panel, is quite a large program. There will be no more disks.
CD-ROM.
It's all CD. So they're going to have a CD-ROM, yeah. This program by itself is about 6 megs, and plus we got a whole bunch of other stuff. So you know what else is coming on the CD? The manual is going to be on CD now. There will be, I think what my plan is to do is to have about 4 laminated sheets with the hotkeys and some basic instruction on it. Then all the rest of the manual will be on CD. If they want to print it off and get a hard copy, they can do that, but I think we're just going to put it on the CD. Options down here. Execute an MX32 script. There's a scripting language that goes along with MX32. So say, and this is how we do it in house right now. We have Galen has a script when he loads boards that automatically loads. He chooses the script for 44 and automatically loads all the right files in all the right places for that. I think probably for end users and distributors, this is probably a useless feature. This is a factory feature, but it's there. What I'm going to do at this point anyways, I'm going to store a file. And this is kind of important. Oops. When you get the store file window comes open, it looks like this. At the bottom is this thing called controller location. Now this is one of those things that's just absolutely critical. There's 4 upper locations and a whole bunch of lower locations. File location number 2 is where the standard init file goes.
Location number 2?
File location number 2, that's for the HSTD, the standard init file. Location number 3 is for the ATC, the tool changer init file. And location number 4 will be for the tangential knife init file. What that allows us to do, if we have these separate init files in different locations, it allows them to run them all on the same machine. It gives us an option at boot up. Do you want to be standard? Do you want to be ATC? Do you want to be knife? But they all have share loader in common. Okay, so I'm going to put the HSTD file in here. Hopefully it's going to transmit. Notice we have a status bar at the bottom that was never there before. It tells you how far it's going, so you can tell if it hoses and locks up and stuff.
Another question. Not that it should even be an issue, but just out of curiosity. Like the machines we have back at the office, if I took this file and installed it, would it work with them as well? No, because the firmware is going to be up.
Thing that says H before it, H standard, H loader, H ATC, H340, whatever, C.bin firmware, only is H board compatible. You can't put it in the G board.
H board being the present board.
H board being with the one with the new keypad. It's got the new keypad.
Like what we saw outside.
That's right. You can put this stuff in it. If it's got the other keypad, you can't put this stuff in it. I don't know what it'll do. It won't work. It'll probably freak out.
Because 116-bit, 133?
No, the controller hasn't. The processor hasn't changed, but all the interface stuff has. Flash too. So I'm gonna send flash. And I'm gonna send this one right here. This is just like sending your flash around. One interesting thing I found out with this, which for some reason the screen redraw makes it go a lot slower. You minimize it, it goes a lot faster. I don't know why that is. So now we set the flash on there, and we want to store some more files. We want the H loader in the user init file location. So what we would call the init file before is now the LDR file. So we'll send that one.
Now this is all more or less stuff that you're doing here. The customer's still probably not going to.
The customer would never do this, but the distributors need to know to do this in case we do a software update or we find a bug and that kind of stuff.
I understand, but I mean, as far as just from a sales standpoint or anything else, the customer, you can just basically give them more or less the same instructions as the other.
History file stays right there. Number of jobs, it's gone. But the DNC really has got no configuration to it because you configure the whole program, not DNC. DNC just uses, before you had to configure the pendant type and the ports and the speed and all that, because DNC was a separate program. Now all that stuff is configured in the control panel output that we looked at the beginning, and all that information is automatically in here. So it's made the DNC component a lot simpler. And the other neat thing about this is you can run them both at the same time. So if you have somebody that's having some trouble with their DNC, maybe you have them open up their terminal window in the background, run DNC. If something happens, have them go look at their terminal window. If there's any errors, it'll be there. So we can get a lot of error feedback information to the terminal window because it's running at the same time as the DNC. Can run at the same time as DNC and as terminal. Now it's all Windows based. You click on each thing over here. There's a help menu on the right hand side that tells you exactly what it does.
Doesn't look like it has as much stuff.
Well, this is only one menu. Okay. When we loaded that, we got a new menu up here called Setup. Okay.
I see.
Setup, input output parameters menu. There's actually more. We want to use step delay. There's also all these other menus. rates menus. All these, this menu and these, actually those 4 menus right there, at a user site, those will be turned off unless they have the / supervisor turned on. But those will be turned off. They won't be able to see those. Slew rates. Again, the cool thing about this is it's got help, online help, ATC menu. Nothing set up for this one yet. Comes over here and it tells you what all it is. So when you get this, you want to open it up and look at old flash file, figure out what they are. You can just go through and look at all the help menus. Let's go ahead and save that. We'll update the controller too. So we can run those 3 at the same time. Session log shows what we did, but we haven't done any system messages back, so it doesn't do us any good. Job queue. You get this right here, error, if you haven't defined a job queue file in your in the control panel output. The very last tab on that was set up the job queue file. So you set that up. We don't have that set up on this one, but it even tells you here, please select motion control icon from the control panel and specify a valid database on the job queue settings tab. So you have to have that done before you can actually open job queue. There'll be an optional, and this is going to be a purchase option for using the machine for a digitizer. I think we'll leave the menu in there all the time because hopefully people say, oh, digitize, I can use a digitizer. Send us $1,000, we'll tell you how to turn it on. Yeah, so it'll be able to use a digitizer. I think I was talking before about RAS host. It comes up with your IP address, your enter host mode, and just we got a firewall. Doesn't work for me. I got a firewall. But we'll be able to hook up from across the internet with this one done. The real important things are we got terminal. Let's do this way. This is kind of DNC and machine parameters.
Machine log and DNC still pretty well.
Yeah.
Okay, here's some samples. There's some more wood samples. This is beautiful. Very nice. Some more
full
samples.
charge battery, I've been able to do.
That's a beauty.
About 50.
That's really pretty.
Yeah, it's
Mike,
pretty.
is there a certain time where the flash just dies out, or?
Actually, if the flash
Another
is going to go,
sample.
you just take the picture if you haven't set the flash.
Very nice. Run yet.
Okay, this is the new keypad. Let's just start in this upper left-hand corner and work from there. Up and down arrows, this is for feed rate override. Instead of the knob, it's arrows. You press down and it goes by percentage, so you can tell exactly the percentage. There's a fast button down here. Press the fast button, and it moves fast. Up and down. So instead of the knob, it's buttons. Okay, spindle speed, it's the same thing. Exit out to feed rate. Spindle speed works the same way. You hold the button down, it goes by hundreds. You hold the fast button down, it goes by thousands. So instead of knobs for spindle speed and for feed rate override, there's arrows, up and down arrows. Starting over here, I'm just going to go ahead and list them off, and then we'll go back and do some of the functions. Set home button, same as the set home button before. Set cut depth. This is the same before. We've moved the maximum depth function is in here also. This is a spindle speed to set the spindle speed, just like the 6 button was on the last control. The fast button, surface, same as the surface button before. Cut speed, spindle test. The spindles enable. Of course, we don't have a spindle up there. This turns the spindle on and off to test to make sure the spindle is working.
If when you press this button, does it just kick on and then turn off automatically?
Turns off until you let go.
So it stays on until I let go.
Until you let go, yeah. You hold it down and it runs. You let go and it turns off.
Okay.
The next button is to activate the DNC like the 8 button was before. Then this numeric pad. 1, 2, 3, 4, and 5 are still programmable homes. 6 does nothing. 7 parks Z. 8 does nothing, and 9 parks the gantry.
Nothing meaning for future.
Yeah, we haven't. There's right now. It's
There's rooms.
Programmed to do nothing.
Okay.
Yeah. Exit, cancel, go home, find home, enter. The pause is a button instead of a big yellow button. It's a little button like this now. Starts. This is a new button that's added for servo enable. If you're on a servo machine and the servo faults, you can reset the servos by pushing that button.
What's the light by it mean?
It means that they are enabled.
Even though this isn't a servo drive system.
Yeah. It means it's ready, basically. If this light were to say start flashing, that means it'll tell you one of the drives is faulty. The up arrow down here is a shift. Some of these functions when we go over there have a shifted function. Hit the shift button and the light starts flashing to tell you you're in the shift mode. Turn it off by hitting it again. The X and Y jog, 4 buttons, same as they were basically before. Instead of having the fast button in the center, the fast button is down here, 2 arrows. And then we've added 2 buttons here for the jog and the Z up and down. Okay, any basic questions yet? We'll start by finding home. This button on the current system, you press it the very first time it finds home, and then after that it's a go home. On the new system, the shifted function, hit the shift button, then that it's a find home. Okay, at any point after that, it's a go home. Same as the current system.
Yeah, but you found home. What if you found home again?
You can find home again.
Yeah, and so that sort of has the same effect as the old menu function of clear all homes. Because no.
Okay, so set home is shift home.
No, not set home. Find home. The very first thing when you do when you power on a machine.
The machine
right now,
Boom.
That's right.
Okay,
Find the machine.
Press
home.
the green.
That's
okay,
right.
right.
Find
okay.
limits or search for the limits.
Right.
Okay.
Okay.
Right now, if your machine stalls, say a machine stalls,
Right.
and you have to refine home, basically you have to e-stop it or power down.
Right.
Okay, you don't have to do that anymore. You can just shift and find home and it refines home.
Right.
Okay, so now then to set home. Okay, I'm moving. I'm wanting to
haven't got
set.
the set home yet.
Oh, okay. I guess that's why I
All
didn't
we've
know
done is find home and go home. That's the
I
only thing.
thought you
we've done.
covered it. I missed it. I
Nope.
thought, wow, Jay,
Nope.
I missed it.
Okay.
Hey, you delayed the class over there,
Yeah, I know.
Let's jog out.
Dumb duck in the class, in the slow one.
Okay. Set home is the set home button. It looks exactly the same as on the other one. Notice that we've moved the go home, set home button so that you don't accidentally reset your home when you're trying to go home. So you press the set home button, it says set home position here. Okay. It's always going to ask you the question when you're going to set up features. We've also changed that to accept any values, like the surface button, you would surface jog down. If you didn't use surface button, you'd hit the surface button again. It doesn't work that way anymore. Any time to accept any value is always the enter key. Enter the cut depth, you hit enter, or enter the speed, you hit enter. So it's always enter.
It always exits.
Yes.
I verified.
Okay, so that's set home. Now we can move the arrows, same. You go home, and just like the current system, it goes back to the set home. Okay.
If you press it again, will it go to machine home?
This one? No, this is set home.
No, you press this one again.
No.
You clear home,
Only
you'd
if you
have to go
clear
in and
home.
clear home.
Okay.
That's right, only if you clear home.
Okay, what if you shift and find home again?
You can shift and find home, it'll find home.
Find home.
And then clear the home that you had set.
That's right.
That's what I'm saying.
That's right. Let's say you want to go back to that location. Before it was located in 0. Okay, we move that. It's the shifted set home. Shifted set home is return to the last set home.
Oh, wow, that's handy.
So instead of being a 0 programmable home, it's a shift and a set home. It goes to the last place.
So as soon as you press shift, it goes on, and you do something, and it goes off.
Yeah.
So it doesn't.
The arrow parking stuff?
What?
Arrow parking, shift the arrows. Is that ever done? Shift up arrows, left arrows, right arrows.
I didn't know anything about that.
Discussed this 3 times.
You and I discussed this?
Yeah.
Send me an email. If it's not written, I don't remember.
It was in that document.
Your desks are 10 feet apart.
I'll see.
You don't exist unless you
Computer
exist in
junkies.
cyberspace.
That's right.
It's
I'm
not in
sorry.
writing, nobody ever said it.
That's exactly right. Okay, so we'll go back to that sit-home position. Okay, 1, 2, 3, 4, and 5 still work the same as far as the stored home. The difference is to set those. Say you want to set one of those homes here. Of course, it's a shifted function instead of the decimal key. So we'll set home number 1. So we can still go back to this one, I think. But now we've also got number 1, which you just hit number 1, enter. One thing we added to the programmable homes is when you move to a programmable home, it parks the Z before it moves. So it's always going to move the Z to the up position. Okay. Stop recording. Okay. Ready? Okay. The next button is the surface button. You press the surface button. The Z keys become active. Just like the current system, you press the 0. It comes down. The surface block is into the spindle. And of course, this surface block isn't wired right. Should have known. We'll pause there. If it was wired right.
What?
What are you eavesdropping over there, Chris?
Yeah, it's not wired at all.
That's all right. We know there's no spindle.
We're gonna-
on
That's
it.
We're gonna
okay.
skip
We
that.
can pretend that
We know
how
that
we do
anyway.
it.
Okay, you know that one.
That's
Yeah.
easy.
Okay. Depth. You can key in the depth. Notice when you hit the depth, it comes up 2 values: the the depth, and the maximum depth.
That is nice. You don't have to
Okay.
remember.
So they're both there.
Oh, oops.
To set the maximum depth, there's a shifted depth. Of course, it's a shifted function. Okay. I don't know if I can set it here. You hit enter, and we once you've set the maximum depth using the surface block, the same way now, you hit the 0 key, you touch out. You go in a function that says adjust max depth. So say you're cutting along and you want to go a little bit deeper. So you pause and cancel, and you're using the maximum depth function, and you just want to adjust it a little bit deeper. You go into the max depth function, press the enter key, and it comes up with this adjust max depth. The up and down arrow keys will let you adjust it. If you want to go
Thousands each.
it'll just make the maximum depth that much deeper
Mm-hmm.
or that much shallower. Now it's a little bit confusing because positive is down on our system. So if you want to go deeper, use the up arrow. If you want to go a little shallower, you can adjust it shallower too.
That could be a
There's no way to change it. That's just
confusion.
how the system
Yeah,
works.
that could be a confusion.
It's the same way the Z works, so
It is the same
Yeah.
way.
the Z moves, so I'm used to that.
Mhm.
It is the same way. So, and then you enter and it'll adjust it. So if we went back into depth now, our max depth is only 7,000 because it was there and we adjusted it down 7,000. Which is probably going to cause us a problem here when we try to run. That's okay. Exit out. So that's the new max depth function. Spindle speed, you press the button and key in the spindle speed. 12,000. So. Okay, so now the spindle speed. It still can be adjusted on the fly with this,
Great.
but this is just where a starting point.
Are you
Spindle test. Go ahead, Jay.
Are you still defaulting to 5,000 RPM?
No, we're defaulting to 18, I think, is what it is, or 24, depending on whose system it is. We're defaulting at the high end and not the low end. And that's, you know, if you run setup in the user default parameters menu, default spindle speed, that can be changed really easy at locations to setup value. Fast button, we've used that a little bit as we go. It's just to make things go faster. We're going to skip the D and C button for now. Zero button doesn't do anything anymore. The decimal button doesn't do anything anymore. Plus and minus only changes values, plus and minus. We went over 1, 2, 3, 4, 5. 6 doesn't do anything. 7 parks the Z. 8 doesn't do anything. 9, parking capacitor, are you sure? table size is a little big.
Mm-hmm.
Okay. Parks moves the gantry back or a moving table moves the table forward.
Question. You said we went over 1, 2, 3, 4, 5. I may have missed it.
Okay, those are programmable homes.
Well, I'm aware of what they are, but how do
Okay.
you set them now if you don't use the period?
It's a shift.
The shift?
Yeah.
Okay. How do you activate them the same way?
Yeah, to set it, say you want to set one here, it's a shift. Say you want to set 5 here, so we shift, go to 5.
Right.
Set home position here, yes, enter. So it's home set right there. Now to access at home, you just press 5.
5 and enter.
Home
So
and
it's
press
the same
shift.
way to access them. I just wanted to make sure.
Yes. Setting them, we just move it to the shift key. It makes more sense than the decimal key.
Sure.
It's a dual function key now.
You got the shift user.
Yeah, that's right. Okay, exit and cancel are the same as they've been. We went over the find home, go home button. We went over the shift key.
Can you go over this one for me since
We're
I'm
going
on
to
the
do that
spot?
right now.
Okay.
We went over the shift key. It's the servo enable button. On stepper systems, it doesn't do anything.
Right.
On servo systems, if the servo faults, you can reset them by pressing that button. It'll blink when the servo's faulted too, and you'll get the usual come up and say like emergency stop, because it also sets the emergency stop circuit off.
Okay, give me an indication of why, you know.
You could never see it on this table.
Okay, but what would tell me that the servo faulted?
This light would be blinking and it would be e-stopped. You have a customer that has had servo faults a couple times. What's that? The start button, it's the same as it always has been. Press start to go, cancel toolboard, start button. Pause button is the same as the yellow button we had before, so we moved it onto the keypad function.
Mm-hmm.
The jog buttons and then the Z. The banner, we changed the banner because we decided we have Multicam up here already.
Mm-hmm.
We didn't need it to say machine automation.
Mm-hmm.
Okay, so we went ahead and we decided we just want to put the X, Y, and Z current coordinates on there so you can tell where you're at. This is all relative to the soft home position too, the hard home position. So say we go up here like this, okay, and it says X minus 1, Y 2. Say we set home here, enter. Okay, now those numbers are 0 because those are all relative to the soft home. The Z is for the surface. 0 would be from the surface. We haven't got there yet. Okay, that's all the hotkeys, basically. All those are covered in that one little document that tells what they do too. To access the menu, it's the same thing. You press the enter key. The first menu item is help. If you press the enter key on the help, it'll tell you press key for help. Doesn't matter which key you press. Say you press this key right here. Scrolls across the bottom. Normal, which is the unshifted mode, and the shifted mode. Say we want to know what this button does. Set surface. That's all it does. There isn't a shifted one.
Excellent.
This one right here, the normal, it's a cut depth. Shifted would be maximum depth.
Idiot proof.
Set home. Shifted.
So you guys actually work
We've
here?
got some idiots.
What?
We service.
So you guys
I don't know
actually
about
work
that.
here?
We'll put that to the test.
It's pretty good. It's a very good feature.
Fast button. Okay. Activated higher speeds. All the hotkeys have a, see some of them like this one, 8.
Mm-hmm.
It's just the 8 key. It doesn't do anything.
Yeah, you spell out the number though. That's very nice.
It doesn't do anything. To get out of the help menu, and this is
I couldn't get out of it.
See, if you
at the
press
show.
the exit, it
Yeah,
says exit. Right?
you keep bumming me.
How do you get out of it? You hit the exit twice, and you get out of the help menu. Okay, clear home. We all know what that is, right? Erases the current soft home position. Oh, this is the other interesting thing we did. The down arrow from help. If you go down once, you now go down to tool lift.
Cool.
Instead of the next page.
There'll be some people that are very happy to hear that.
Tool lift is the same as it always has been. Move, same as it always has been. If I go over something that I said it's the same, if I say it's the same and you don't know what it is, speak up. Material cutoff, that hasn't changed. Jog hasn't changed. Job time hasn't changed. Cut conditions hasn't changed. HPGL hasn't changed. Mistest hasn't changed. Table mill hasn't changed. Test cut hasn't changed. Digitize is something new. Digitize is going to be a purchasable option. I am. I can't speak. What it is you'll be able to use the router table.
Oh,
I am having trouble
that
today.
is getting bad.
The router table as a digitizer. I think we're going to leave the menu in here so that we can, because it is going to be a purchasable option. So then maybe they'll say, "What's this?" Oh, for another $1,000, you can have that.
Will you be showing us some table and how to do that today?
Not today because it doesn't work yet.
Okay.
It may work. I just haven't tested it. It's right now. It's not on the top of the priority list.
What's the concept of it?
The concept of it is you got the router head out here, right? You have a part you want to duplicate. You bring the router head over to here and you enter a point. You bring the router head here to enter a point. You bring it here to enter a point. You bring it here to enter a point.
So that would be cutting a
You
square.
close and that will cut a square.
Cut a square.
Or I think there's going to be arcs in there too, so you can say here, here, and here is a 3-point arc. Here, here, and here is a 3-point arc. There's some things like that. I don't know exactly how it works.
Right.
It has been a low priority, but it is. I think we sold it, so it's going to work. It's not a if. It's just a probably within the next 2 or 3 weeks. I'll have time to do that. Multi-pass. Do you guys have machines with multi-pass yet?
Yes.
Okay. This hasn't changed.
Not on. I don't have it on.
No.
On the
you
box. I
haven't.
have it inside the software.
Yeah, there's a multi-pass function for the new controller. It's been on probably the last maybe 6 months of the other controller. If you use an HPGL file that's strictly a 2D with no depths, and you key in the depth with the depth button, you can come into the multi-pass function and set what we call byte size. Now, if the byte size is 0, multi-pass is turned off. Say you key in a depth from your depth command of 1 inch, and you come in and you take your multi-pass byte size of say 0.25. It's going to do each contour 4 passes a 1/4 inch deep.
Very cool.
I didn't even know that. That's what a bite size is.
Has this been shipping on the machine?
Yeah.
So
I
it
didn't even know
automatic-
about this function.
Yeah, it's on there. It's one of the last functions.
Let me ask something. All right, it automatically.
Don't you know about that?
It only works if you use HPGL 2D files with no depth inside the
In
file.
other words, if you
Okay,
like output
can
a
I
big
override
file.
this feature from the software?
Yeah.
All right, I just don't put it in here, and the software will do whatever I
Yeah,
say.
yeah. If
Software
you're
always
multi-passing with the software, then this doesn't do anything for you because you're not using a 2D no depth HPGL file.
Like if you're outputting straight from
What if-
Tasmania
Yeah,
or
but the
something like
beauty
that.
behind the multipass that's in here, though,
Mhm.
is what it does
Or
is it
anti.
takes each independent contour, so like each closed contour, and it will come down, it'll mill that contour, move down, mill that contour. It never tool lifts back up out of the material. It just continues to move down, so it saves a lot of time.
Doesn't lift.
Secondly, the ordering's perfect because it completes each internal, like it's an A, it'll complete the internal part of the A, then complete the external part of the A, then complete the internal, and it'll do all the passes on that without ever lifting the tool. So the time savings is very good over the
So
That is really
it
good.
won't come up. It'll just keep going.
yeah,
you're saying.
So
go
it
around,
almost- it
then
al-
use Z speed and go down. Go
Yes.
around,
Okay.
Z
So it
speed,
takes
go
a
down.
2D
Another
file
question.
and in a sense can turn it into a
If you tell it
3D
half
file
inch,
like an
half
invoice.
inch material, all right, but you program 0.3 depth,
Mhm.
bite size. All right, what's it gonna do? 0.3 and then go down to 0.2?
Yeah.
It'll mathematically figure it all out?
Yeah, it always just does the remainder.
Does the
So
remainder.
let's say the perfect world would say, yeah, let's say you're going to do a half inch and you tell it to go 0.15 at a time. It'll go 0.15, it'll go 0.15 again to get into 0.3, go 0.15 again, now you're at 4.5, then it does the 0.5 that's left.
Oh, that's great. This way you get a, have
It's
some
really
sort of cleaning
good
pass or
feature.
something that's
Bothers me that it's been
All right.
I didn't know.
Yeah, well, if it was
it's
on.
very good. That's
But
excellent.
it's not
But
on
it's a
our
cool
demo.
feature because you can take a simple file,
Been in the manual.
do it with it, and it completes each contour without lifting the Z.
That's
And
why we
without
need
lifting
new
the Z
demo
was a big deal
machines.
to us.
That's a very big deal.
Your machine has it.
No loss.
My machine,
No
my
lost
demo
time.
machine doesn't
Who
have
thought of
it.
this one?
Guaranteed, both of your demo machines.
Yeah, yeah, yeah,
have it.
bullshit.
It's serious.
My baby, man.
Absolutely.
He's trying to take the
This has
credit.
been
We'll take
in
a
there
look
for
when we get
months.
It was your idea,
Yeah,
wasn't
take
it?
a look.
What was?
You're buying donuts.
It's a very good idea.
Down here is auto and all. I don't think we can probably go. This is replaces for the multi-head system. This will replace the auto and all switch. It's an electronic switch now instead of a mechanical switch. See out there?
Yeah.
Exit out there. The only two buttons we have up here, and this one doesn't have the label on it yet. Emergency stop, big red button. Spindle enable. All the other ones are gone.
How you doing, Mary?
That's pretty much all the functions of the new keypad.
Action.
Say you set up a job and you're getting ready to run and you want to use the DNC. As long as the DNC is going in MX32 and the cable's connected, press the DNC button. It says connecting to host, verifying loading. Then you get the list of directories, the same as you're getting now. So say we go to, here's going to be small enough. Let's just go to MCFF or MCSF. Press the enter key. You go to your files. Now the two dots will take you back to the previous upper level directory.
It's just like computers.
Yeah. If you say you hit exit, it takes you all the way out, which is
So
different.
exit, you don't exit and then exit.
Yeah, exit takes
just
you
exit
all the way back
that's
out.
that's good though. I like
Okay. One thing this also allows us to do is do multiple levels of directories. So say you have a jobs 1 directory and underneath jobs 1 you have a Monday, you can access that directory now because it'll show up here as brackets instead of just files. Let's go back over this one. There's nothing under here, but if there was, the new directories would be brackets and the files would be files. Let's see if we have anything.
How many levels?
Let's try this one. Whatever.
Standard Windows.
Yeah, it's a Windows type thing. Okay. Yeah? Now, you press the enter key. It shows you the name of the file with the full extension, the size of the file, how many kilobytes, the date and time it was created. So you get all the normal type. If you were looking at Windows Explorer, it'll give you the same information. So you can tell what date it was created and what time.